In the U.S. alone, there are less than 2 million EVs on the road today. That's 2.5% of the total car market. And President Biden set an ambitious goal for 50% of all cars sold in 2030 to be zero-emission electric cars. But here's the thing. All EVs have one thing in common. They require a lot of minerals. In fact, you need 6 times more minerals to produce an electric car compared to a conventional combustion engine car. Among these critical minerals include rare earth metals. If the U.S. wants to meet Biden's EV goals, we need 10 times more rare earth metals than we currently have. The problem is, we can't meet that volume with domestic supplies alone. We're heavily dependent on foreign sources. If you see it from a bigger picture, it's not just about the U.S. achieving a greener economy. It's not even about impacting the entire U.S. economy. It's also about national security. Today, we're looking at how EVs are eating up rare earth metals. Rare earth elements are a group of metals which are critical for a greener economy. They're used in EV drivetrains, for example. Here's the irony. Rare earth elements aren't really rare. They're not nearly as rare as precious metals like gold or platinum. Actually, rare earth metals are pretty abundant in the Earth's crust. But the problem is, they're rarely found in large concentrated deposits on their own. Instead, we can only get to them by separating them from other elements. This is a dirty and labor-intensive job. The countries that produce the rare earth metals include China, Australia, Brazil, Canada, and the U.S. These metals aren't only used in EVs. They're needed for pretty much everything from F-35 Stryker jets to wind turbines, medical equipment, semiconductors, and even cell phones. So they're super critical to supply chains, and it's obvious why they're in high demand. There's a private company called USA Rare Earth. They're developing mines in North Carolina and Texas. The plant in North Carolina is expected to be fully operational by the second half of this year. It's essentially the one and only magnet plant in the U.S. It can produce 20% of the permanent magnet demand. USA Rare Earth is also developing a brand new mine in Texas. It's called Round Top Heavy Rare Earth Lithium and Critical Metals Project. The mine in Texas is expected to be fully operational by 2023. All in all, it's expected to produce 15 of the 17 rare earth elements, plus other minerals like lithium, gallium, hafnium, and zirconium. If you think that'll solve the U.S. supply problem, the truth is, even if the Texas mine exceeds all predictions, it still won't be enough. Till now, the U.S. has been relying on one major country for years, China. Pini Altus, the CEO of USA Rare Earth, said the U.S. at least would need 4 or 5 round-top mines to get even close to independence from China. And yes, for sure, the U.S. could continue to rely on mines in Australia and Canada, but Altus doesn't believe that's such a good idea either. In fact, he considers that foolhardy. One major reason is around regulations set by CFIUS, which is an interagency committee chaired by the U.S. Treasury Department. It reviews foreign investments and acquisitions of U.S. businesses and real estate to determine if the transaction threatens U.S. national security. The problem is Australian-Canadian project owners don't have any CFIUS regulations. That means they don't have to sell to the U.S. They can sell to anyone, even China. Believe it or not, some Australian companies already have off-take agreements with China in place. So the U.S. can ask Australia and Canada for rare earth metal, but it doesn't necessarily mean we'll get them. And if Australia or Canada give their metals to China, it will just make China even more powerful. The U.S. wasn't always in this predicament, though. Not many people know this, but from the 1960s to the 80s, the U.S. was the world leader in rare earth metal production. But then they turned to China because of its cheap labor cost and the environmental footprint that production leaves behind. They wanted to leave behind China, not the United States. And of course, the thing is, the U.S. never looked back until now. The U.S. doesn't necessarily need to cover 100% of our own needs for rare earth metals. It's believed that even 50 to 60% may help ensure that the global supply is not weaponized by China. China has been the key dominator of the rare earth metals for years now. Vietnam and Brazil follow next, and between them, it's almost a tie neck to neck. But China's outproducing everyone by a landslide. Let me put this into perspective. The U.S. has 1.5 million tons in reserves. China has at least 44 million tons in reserve. In 1985, China introduced a policy that partially refunded the taxes paid by domestic producers of rare earth metals. This lowered the cost for Chinese mining companies. Add to that some lax environmental regulations and cheap labor, and that's how China's rare earth metal industry suddenly got very competitive. Its production ended up increasing 464% between 1985 and 1995. In 2010, China slashed its rare earth metal export quotas by 37%. This pushed rare earth metal prices to all-time highs. rise. That fueled an influx of capital into the rare earth mining industry, and it also kick-started mining in other countries. China used to mine 90% of the rare earth metals worldwide. Today, they're down to 63%, but that's still a lot. That's 140,000 tons of the 240,000 tons that develop globally. China also controls 85% of the processing. The United States produces 38,000 tons, but the irony is that it ends up all being sent to China for processing anyway. In 2010, there was an international disagreement over territorial waters, so China cut off supply of rare earth metals to Japan for 40 days. So you can see how much power and control they have. China used to own 3 rare earth companies. Now they've combined them into one. It's called China Mini Metals Rare Earth Company, and they have no plans of slowing down anytime soon. China plans to build 6 million EVs by 2023. All those new EVs will need a whopping 30,000 tons of rare earth metal. But it's not just China that wants to ramp up its EV production. This year, 2022, seems to be the year of the EV from what we can see so far. Ford announced it was doubling production of its all-electric F-150 Lightning to 150,000 vehicles a year. GM then announced the new electronic version of the Chevy Silverado pickup truck. Even Sony presented its concept for a new EV. But those aren't the only companies with big EV plans. There's also Cadillac, BMW, Mercedes-Benz, and Hyundai. Even EV companies like Lucid and Rivian are racing full steam ahead. The days where Tesla was the only car company generating buzz are long gone. But there's a problem. It's getting very expensive to keep up with the demand. The prices of critical metals needed for EVs are skyrocketing. Lithium went up as high as 500% year over year last month. Cobalt went as high as 80%, and nickel went as high as 33%. Battery costs are dropping a few years ago, but the prices of metals doesn't seem to be dropping anytime soon. And since they are a critical part of batteries, battery prices are rising because of this. Battery makers have even gone so far as making public announcements that prices will increase. Another problem is the fact that mining operations for rare earth metals are highly concentrated in only a handful of countries. We're talking about a lack of diversity. And this brings a host of geopolitical concerns. For one, each of these countries have their own climate agendas. This means they need resources too, so competition is even more intense. Now, most car companies are aware of the price increase and supply limitations of rare earth metals, so they get prepared. Take Tesla, for example. They're already way ahead of the curve here. Did you know that Tesla has preemptively been making a bunch of direct partnerships with miners instead of working through battery suppliers? They went straight to the source. Last month, Tesla struck a deal with Talon Metals for US-based nickel, and they struck a deal with Australian-based Syra Resources for a line on graphite that's sourced from Mozambique. These 2 deals are enabling Tesla to start diversifying its supply chain outside of China. It's quite brilliant and forward-thinking, if you ask me. Ford is also getting more involved in the production of EV batteries. Last year, they announced plans to build 2 battery plants, one in Kentucky and one in Tennessee. They're doing this in partnership with the South Korean battery cell supplier called SK Innovation. True, they're not partnering directly with miners like Tesla, but they are placing themselves right in the middle of the battery business. But the most interesting thing of all this is that it's never been done before, at least not successfully on this scale. In the past, whenever someone tried to get involved in the materials end of the business, didn't end up too well, especially when it comes to mining. Mining has been under the radar for years now because of its track record of labor abuses and heavy environmental pollution impact. But car manufacturers are desperate. They see that the demand for rare earth metals far exceeds the supply. That's why they're racing for raw materials. Because if the clock strikes 12 and they don't have any raw materials, they're going to be left behind by those who have access to the supply chain. So they're scrambling, even if it means building more mines that end up hurting the planet more than helping it. Opening a mine in a safe jurisdiction takes years. Just think about the applications, permits, design work, financing, construction, and commissioning that's required to build a mine. The regulations are very strict. All in all, you're looking at 8 to 10 years to open a mine for your metals. And then there's China. Put simply, if you want to open a mine in China and the state agrees with you, bam, and it's yours. The fact of the matter is that we can't just stop mining tomorrow. It doesn't work like that. Rare earth metals are present everywhere in your life, even in your cell phone. And today's society is heavily dependent on them. That's why many companies are adopting environmental, social, and government standards to reduce the negative and hazardous impacts from mining. GM is taking it a step further. They developed the Ultium family of electric motors for the company's large array of planned EVs. With these new motors, GM hopes to reduce the need for rare earth metals. The smallest member of this new Ultium family is an 83 horsepower induction motor that will be used on all-wheel drive assist duty. The main EV drive motors are the 241 horsepower front drive motor and the 342 horsepower rear motor. Both these motors retain their permanent magnets. For example, GM's plan to whittle the use of rare earth metals down to the bare minimum. And it's not like this approach is totally new for them. They've done this before with the use of precious metals in the catalytic converters for the combustion engine cars. Anyway, the first production car you'll see rolling into showrooms with the Ultium motor will be the 2022 GMC Hummer EV. This EV will have 3 of the big 342 horsepower motors when it arrives later this year. And they insist that they have secure, sustainable, and ethically sourced materials. Well, one thing's for sure, it's a mad dash for metals, and the competition isn't slowing down anytime soon. But now, you tell me, do you think the U.S. can grow even less dependent on other nations for rare earth metals? And will any country ever overtake China's top spot in rare earth metals? Please share your opinion by commenting below. If you like this video, please like and subscribe. Thanks for your support.